Hello everyone, welcome to a new I-Greta Pathway to Power interview. We are in the microgrids lab laboratory at National University of Science and Technology, Polytechnica of Bucharest, and our guest today is Radu Plămănescu, lecturer at Electrical Engineering Faculty. Radu, your research profile is measurements in power systems. You have also a PhD on this topic. So why did you choose measurements?
Thank you so much. And first of all, I thank I-Greta for this opportunity to discuss about our work. Welcome, first of all, to our laboratory here at Faculty of Electrical Engineering. In the laboratory, measurements for emerging power systems, a lab dedicated for both teaching and research. And I'm happy to discuss today some of our topics. Why measurements? Well, it's of course not a straight answer. It's a continuous journey that of course begin and continuously grown alongside my supervisor for the PhD and my professor Mihaela Albu. She's the coordinator of our work here at microgrids lab. There is no straight answer, as I said. Probably I have in mind the words of Lord Kelvin that I oftenly found it in the field of to measure is to know. So of course, if we want to evolve if the power system would like to evolve it, especially nowadays with the transition of the power system, of course, we need measurement information.
So Radu, I see you are highly involved in research projects about renewables, about increasing flexibility of distribution network through advanced measurement infrastructures. So can you tell us more about the projects you're involved in?
Thanks so much for the question. I will try to briefly explain, get a bit into more details. Of course, our, let's say, history began a lot of time ago. Of course, I was not involved in all the projects, but I will try to summarize some of the ongoing projects that we are working on. You see a lot of things happening. Just to mention before the project, just to mention that our research group, it's also part of the European network called their lab. A network with a lot of advanced infrastructure laboratories, and of course we are also part of this network. All the projects that we are involved in somehow relates with the measurement paradigm, with the measurement infrastructures. One example, one of the recent projects that actually it started with I-Greta 4 years ago, and now the follow-up of this project, Econ for Future, that tries to integrate and create like an open source platform to integrate measurement information with high reporting rates and take informed decision also based on flexibility in operation, information from the generation on the load side as well. So just briefly a bit the infrastructure, how it connects everything, and how this open source it's operating. And our demo site consists of let's call it energy community enabled by a microgrid, a small microgrid with 2 houses that exchange energy. Another project that I might want to get into, it's called INFUSE. It's a newly funded project. It's an ERANET funded project. Here we want to extend the capabilities of the platform also with real-time digital simulation environment. So we want to extract data and create models, advanced models for energy communities, for the microgrids that we are monitoring using an open source platform. Another project a bit more special, it's called CARDEA. It's a Horizon Europe project that is dealing, and it tries to define and creates the research manager as a profession, which is still not defined at European level. And just to finish with all our work, just briefly, we also hosted a microgrid symposium almost 6 years ago. But our group, myself and Professor Albu, we are part of the international steering committee of this symposium that it's happening every year on a different continent. And of course, I mentioned microgrids, so microgrids are part of our also research interest.
When I entered the room, I saw some state-of-the-art measurement instruments, and you've also mentioned about the measurement infrastructure used in your research projects. Can you give us a little presentation about the devices used in your research?
Of course, that would be my pleasure. Of course, we are not on the field, but being in a lab, we have some panels here that we use them for conducting the preliminary research and then deploy all the equipments in the field. So, of course, we need to move a bit to the panels to better explain this infrastructure. We have here some examples of smart meters, three-phase and single-phase smart meters. With additional single-core processing units, and we have access to 1 frame per second measurement information, of course, for application in the low voltage side. If we want to discuss to move further, we have the PMUs. We have 1 PMU and 1 micro PMU here. Used for monitoring and control transmission level with up to 100 frame per second reporting rate. And I would say one of the most relevant, but this is a power quality analyzer that can be directly connected with sampling frequencies up to 50 kilohertz. And depends on the application, we can have access to a lot of information that we can further investigate. One thing that I would also like to mention being here, we have also real-time digital simulation capabilities with hardware-in-the-loop environment. We have a Typhoon Hill simulator that in one of the projects that I mentioned earlier, we'll use it to develop models for the microgrids and for the energy communities that we are currently investigating and model based on the measurement information.
So you have really interesting devices here in the laboratory, and I'm glad that students have the opportunity to work with state-of-the-art instruments. It is clear that measurement infrastructure will develop as the new real-time applications appear, but how do you see the development of the communication infrastructure needed to transmit the data into the network? What are the challenges here?
I will try to answer this question by giving some examples of the work that we are also trying to implement with the help of students, but also in our research projects. Of course, with all the high and very high reporting rates from all the monitoring devices, we are trying to extract knowledge from all those measurement information, and we are trying to process the information at local level, and then based on relevant metrics, we can export them to a more centralized architecture. So we are trying to come up with new ways of avoiding sending too much data and try to extract knowledge at the process level.
Continuing on this topic, would you go with centralized or decentralized architecture of communication?
Well, it's a very good point. As mentioned before, on a lot of our work and in a lot of the scientific papers that we've published, of course, we take both directions. We cannot integrate in the cloud all the information available with very high reporting rate, and then we expect someone in a centralized way to compile out those data. It depends, of course, on the application. So we are talking about the microgrids. So for the microgrids, for example, we can have local infrastructure, we have edge computing, we can extract knowledge at the microgrid level and only send certain information at a higher level for the, let's say, for the distribution operator to send only some relevant data. So they should go both hand in hand. So decentralized, of course, edge computing at the process level, but to send to the DSOs, for the distribution system operators, only relevant information so they can have the awareness of increased awareness over the whole grid.
In the end, Radu, I would like to know from you what's your opinion about the opportunities raised by these high resolution measurement instruments on developing and integrating new technologies in power systems.
Well, of course, there are many directions that that we can follow. I can give you, let's say, one direction that we are pursuing. Let's say we have the real-time digital simulation capabilities here, and with the help of real-time measurements, high reporting rate measurements, we can identify and we can create better models for all the elements in the grid and integrate them in the real-time simulation. And then with hardware in the loop and control hardware in the loop experiments, we can develop and we can integrate, test, prototyping new technologies. We can use power amplifiers to connect real devices that can be controlled using for example, the real-time digital simulation. So I would say we have access to high resolution information, but we extract knowledge of them, and then we can integrate everything in one simulation environment to test real hardware with hardware in the loop and power hardware in the loop experiments. That can be one direction. And of course, all of the equipments, we have the power electronics mediated energy transfer. We can test it using the simulator and not going into in the real field. And we can do whatever tests to develop such equipments. That might be, and this is a very active field of research also here in our lab.
Thank you, Radu, for this insightful discussion. I wish you success in your following work, and I hope we'll meet again for another interview to discuss the results of these interesting projects.
Thanks so much, Radu, and the I-Greta team for this opportunity. Of course, I am just a small, let's say, in the part here in Microder Lab. Of course, I have to also thank to all my collaborators, all the team members. That, of course, without their help, this let's say research environment and teaching environment will not be possible.
Okay. Thank you too for watching this video. Don't forget to subscribe and stay up to date with I-Greta Next Generation Network Romania.